This video is over section 7.1, Quadratic Functions and Applications. There's a lot of vocabulary here before we get into the problem, so be patient with that. A quadratic function, there's a lot of things that we could put here. For now, just for time's sake, I'm just going to make this shape here. It's going to make a parabola shape. Okay, when we graph it. Quadratic functions have common second differences. I don't want to get into all that, but basically there's a lot of things that we could put here. For now, it's going to make this shape. It's probably it can be written as the form ax squared plus bx plus c equals 0, where a is not equal to 0 and a, b, and c are real numbers. Okay, I don't want to get too into it there because it's really not the purpose of this video, but an axis of symmetry is a vertical line through the vertex of a quadratic function. You can have axis of symmetries not through quadratic functions, but for the purpose of this video, we're going to be looking at quadratics. And then vertex would be the turning point of the parabola. These are not formal definitions, by the way. I'll put quadratic function instead of parabola. Okay, vertex form is going to be a times x minus h squared plus k, where hk is the vertex. The x-intercepts is where the graph crosses the x-axis. And for a quadratic, there's 0, 1, or 2 times. Or that happens 0, 1, or 2 times. The y-intercept is where the graph crosses the y-axis. That'll happen 1 time. Maximum minimum value. If a quadratic is looking like this one has a maximum at the vertex. And if the graph is looking like this, it has a minimum right here at the bottom. The domain is all possible x values. And the range is all possible y values. A lot of vocabulary there. Feel free to pause if you need more time to catch up. All right, given x minus 3 squared plus 5, determine whether the graph of the parabola opens upward or downwards. So I guess up here, let's take a second and look at vertex form. So a times x minus h squared plus k. I said that, let me just look at my notes real quick. Yeah. Okay, I said that h comma k was the vertex. And we didn't really talk about a. So when a is positive, so when a is greater than 0, that means my graph is opening up. And when a is less than 0, that means my graph is opening down. Okay, when the absolute value of a is less than 1, that means my graph is compressed, meaning that it's getting like flatter. And when the absolute value of a is greater than 1, that's a stretch, meaning the graph is narrower or skinnier compared to like the parent function or the original. That should not be like a totally new concept. I'm kind of rushing through that, but if you have a question, let me know. So it says given g of x equals x minus 3 squared plus 5, determine whether the graph of the parabola opens upward or downwards. This one opens upward because a is greater than 0. That a right here, you can't see it, so that would be a 1. Identify the vertex, so the vertex is HK. So the vertex for this one would be 3, 5. Notice here that the formula has a minus sign in it. And so we just look at the number, not the minus sign. So that h would be 3. X-intercepts means that y is 0. So if y is 0, we're going to have 0 equals parentheses x minus 3 squared plus 5, and we need to solve for x. If I subtract 5, I'm going to have negative 5 is equal to x minus 3 squared. Now to get rid of squared, I'm going to square root. And in previous chapters, we did square root negatives, but if we're trying to graph and we try to square root a negative, that means that there's going to be no x-intercepts. So we can just stop there. Determine the y-intercept. We're going to plug a 0 in for x. So that's going to be y equals 0 minus 3 squared plus 5. So this would be negative 3 squared plus 5, which would be 9 plus 5. So the y-intercept here would be 0 for x, 14 for y. And then it says sketch the functions. So if I have just a rough sketch here, 3, 5 will be my vertex, and then my y-intercept is going to be at 14. 6, 7, 8, 9, 10, 11, 12, 13, 14. It's going to look like so. Because of symmetry, so the axis of symmetry would be here. I'm 1, 2, 3 steps away from my y-intercept at 14, so I can also go 3 steps this way and get a dot at 14 as well. So let me back up. So right here I can add a dot. That's at, that would be at 6, 14 by symmetry. Okay, so we did this here. The axis of symmetry would be x equals 3. Determine the maximum minimum value. The minimum value, so minimum of, that one would be at 1, 2, 3, 4, 5, at x equals 3, and that's always going to happen at the vertex. And then write the domain and range and interval notation. So the domain would be all real numbers, and the range starts at 5 and then goes up. So it would be 5 to infinity. All right, given h of x equals 3x squared minus 6x plus 1, determine whether the graph of the parabola opens upward or downwards. We're given a different form, but a is still positive, so this one opens upward because a is greater than 0. Identify the vertex. So here's a new formula. B is equal to, or not B, h is equal to negative b over 2a. And we use that when we're given standard form. So up here we were given vertex form. Let me write that. I'll write that here too. Okay, but standard form is just no parentheses. So when we're given standard form, we can use this formula here. And when we do that, we're going to have negative, negative 6. Sorry, this is A, B, and C. And 2 times A would be 2 times 3. So we're going to have 6 over 6. So my h is 1. And to get k, we're going to plug in 1. So that would be 3 times 1 squared minus 6 times 1 plus 1. So k is going to be, let's see, negative 2. So my vertex would be 1 comma negative 2. For x-intercepts, we're going to plug a 0 in for y. So that would be 3x squared minus 6x plus 1. There's a lot of different ways to solve this. We could factor it. I think this one does factor. Actually, no, it doesn't. Maybe. No. Okay, so we can't factor this one, so we're probably going to have to do quadratic formula, which we've learned before. It might have been a while, so go slow if you need to, or go back and review that video. So negative b plus or minus the square root of the discriminant over 2a, and I like to do that separate. So b squared minus 4ac separate would be negative 6 squared minus 4 times 3 times 1, which would be, I'm going to use my calculator so I don't make a silly mistake. 24. So I'm going to take that and put it here. And negative b would be positive 6, plus or minus the square root. I'm going to break down 24 into 6 times 4, all over 2a, which would be 6. The square root of 4 right here is 2, so this would be 6 plus or minus 2 square root 6 all over 6. And this is so confusing, but we're trying to find the x-intercept, so we just need to remember what we are doing. So let me move all this over a little bit. Okay, so we have two x-intercepts, and x-intercept means that the y is positive. I'm going to go ahead and reduce this because all three of those numbers can divide by 2. So my first x-intercept is going to be 3 plus the square root of 6 over 3 comma 0. And my second one is going to be 3 minus the square root of 6 all over 3 comma 0. So there's my two x-intercepts. Kind of crazy, but quadratic formula is all that we're doing. If you really wanted to get a decimal here, you could. I didn't feel like it. All right, determine the y-intercept. So y equals, we're plugging in 0 for x. So we have 3 times 0 squared minus 6 times 0 plus 1. Notice this goes to 0, this goes to 0, so my y-intercept is 1. If I wanted to write that as a point, it would be 0, 1. Sketch the function. We've got points right here, so I guess I probably need to find the decimals. Let's do that for now. So 1, negative 2 would be my vertex. Excuse me, sorry. 0, 1. By symmetry, I could get another point here. And I'm not going to find them, but these two x-intercepts are right there and right there for some decimal. And we could guess. Axis of symmetry is going to cut through my vertex, and so my axis of symmetry is going to be x equals 1. Maximum or minimum value happens at the vertex, so that is a minimum, and that's a minimum of negative 2 at the vertex, so at x equals 1. The domain and range. Domain is all real numbers, so negative infinity to infinity. The range, the y value starts at negative 2 and goes up, so negative 2 to infinity. All right, the population P of T of a culture of the bacterium, I'm not even going to try to say that, is given by P of T equals negative 1718 T squared plus 82,000 T plus 10,000, where T is the time in hours since the culture was started. Determine the time at which the population is at a maximum, so that would be vertex. Okay, round to the nearest hour. Okay, so because we're given a standard form, we've got A, B, and C. To find the vertex, we're going to do H equals negative B over 2A. That would be negative 82,000 all over negative, 2 times negative 1718. And I'm going to use my calculator so I don't mess up anything. I hope I didn't mess something up. I don't think I did. Okay. I got 23.86. I run to the nearest hour, so that would be about 24 hours. And we know t is time, so the t or the x value would be h. Put a little equals t out here. And it says determine the maximum population, so we're going to plug in that 24. I'm going to plug in this number to be safe, but it's probably going to be pretty close if you just plugged in 24. So p of 23.86 is equal to negative 1718 times 23.86 squared plus 82,000 times 23.86 plus 10,000. And again, I'm going to use my calculator because I do not want to mess that up. and I got 9,884,63.287, and it says nearest thousand. So 1,000 would be this place. So that is approximately 988,000. And population. I'll just put population of bacteria if you really wanted to.